Hey guys, Mr. Brown with Quarter B Final Review IHD Edition, Chapter 8, Part 2, Radical Functions. Alright, so this was another fairly short chapter in its IHD form. We converted between radical and rational exponent forms. We simplified radicals, and then we solved some radical equations. So let's take a look at some of those. So our rational exponent to radical form, that is this top part. So these are the two equivalents. When you're converting between the two, right, the exponent, if it's in radical form, becomes the numerator in rational exponent form. And in radical form, the root becomes the denominator in rational exponent form, and vice versa. All right, so simplifying. So something like this, you are looking to make groups. So in this case, if we're looking for the cubed root of x to the fifth, we are looking for how many groups of 3 we can get out of here. And one way to do this is to write out 1, 2, 3, 4, 5 x's, because x to the fifth, of course, is x times x times x times x times x, so there's 5 of them. Now, I've got one group of 3 and 2 left over. That means that 1x comes out and 2x's, or x squared, remains in the radical. With numbers, we can do this with a factor tree. Now, if it's a square root, there's no number here. We're looking for groups of 2. And so this could go to 4 and 12. That could continue to 2 and 2. The 12 would go to 4 and 3, and the 4 would go to 2 and 2. So now I've got two groups of 2 twos, and so this is going to equal 2 times 2 comes out, which is 4, and 3 stays in, which is 3. So the ends of our factor tree branches. All right, then solving. So when it comes to solving something like this, what I'm trying to do is isolate x, right? What I can't do is start by adding 3 to both sides. That's not going to work. I have to get rid of the outermost layer first, and the thing that is blocking everything right now is this square root symbol. I can't take this out of the grouping symbol until I get rid of the grouping symbol. And I get rid of it by squaring both sides. That is going to make this 1 equals 2x minus 3. And don't forget the end goal here. We're trying to solve for x. So think of how you solved this in Algebra 1. Two-sided equation, right? We'd get rid of the minus 3 by adding 3 to both sides. That will give us 4 equals 2x. Then we get rid of the times 2 by dividing by 2, and we get that x is equal to 2. Now, these are the ones where it is a good idea to double check your work by plugging in that 2 back into the original equation to make sure it actually works and it's not an extraneous solution. So that would be 1 equals 2 times 2 minus 3. 1 equals the square root of 2 times 2 is 4 minus 3. 1 equals the square root of 1, and the positive square root of 1 is 1. So that one checks out. That one is good.